You know, we've all seen them, these scientific-looking papers or claims online that are just so dense, so chaotic. You can't tell if they're absolute genius or total gibberish. Well, today, we're going to walk through a real-world example and show you a powerful way to turn that kind of scientific mess into perfect clarity. Okay, so this is our case file. At first glance, it looks legit, right? I mean, you've got graphs, you've got technical labels, all the things you'd expect to see in a scientific paper. But the more you stare at it, the weirder it gets. The text is a jumble, so what are we looking at here? Is there a brilliant idea hiding in plain sight, or is it just noise? And that's the real problem, isn't it? When a claim is this messy, how do you even start to investigate it? You can't just throw it out, but you can't just accept it either. What you need is a system, a reliable process to figure it out. So here's our game plan for cracking this case. First, we'll dig into our cosmic mystery file. Then, I'm going to introduce you to a kind of detective's toolkit for this exact situation. We'll use it to build a real, testable hypothesis, learn how to dodge some common scientific traps, and finally, map out a clear path to the truth. All right, let's put a name to this thing. Buried in all that chaos is a claim, and it's called the Solar Circuit Hypothesis. Now, in plain English, it's suggesting a brand new, direct link between what the sun is doing and some very low-frequency radio signals here on Earth. That's the core idea we need to put under the microscope. But the problem is, the idea is presented in this jumbled, jargon-filled mess. So to get anywhere, we first have to cut through all that noise and find the simple, testable idea at its heart. It is the absolute perfect challenge for the method we're about to use. To solve a mystery, you need the right tools. And for this, we're going to use something called the Holmes Audit Framework. And yeah, just like the name sounds, you can really think of it as a detective's toolkit, designed specifically to untangle these super complex scientific claims. The framework even has this motto that sounds kind of like a pre-flight checklist for a rocket launch, right? And honestly, that's exactly the point. It's a systematic procedure you follow before you even start the real investigation, just to make sure everything's locked in and you're ready to go. So, what's it actually do? Well, put simply, the Holmes Framework helps you take a messy idea and systematically sort out the established science from the new speculative parts. And this is so important because it lets you design a clean, fair test that focuses only on the new claim. Okay, with our toolkit in hand, the real investigation can begin. Our first job is to apply this framework to that initial mess and pull a clear, testable hypothesis out of the chaos. The framework starts with 3 really clear steps. First, you just rephrase the core idea into a simple statement you can actually test. Second, you sort all the little supporting claims into 2 buckets: known, as in established science, versus speculative, which is the new stuff. And third, you flag any gaps where you just don't have enough information to go on. And here's what that sorting process looks like in practice. In the known bucket, we put the stuff that's already solid science. We know the Earth has an ionosphere. We know there are standard ways to measure geomagnetic activity, things like the KP and DST indices, which are basically just scores for how much the Earth's magnetic field is wobbling. That's our solid ground. Then, in the speculative bucket, we put all the new ideas, the solar circuit concept itself and this proposed link to the solar wind. This is the crucial part. We're not retesting all of physics. We're focusing our energy only on the new claims. Now that we've totally isolated the core claim, we can design a specific test. The plan is actually pretty simple. Take real-world data on these radio signals and compare it, side by side, to data on the solar wind and geomagnetic activity. And we're not just looking for any old connection. We're searching for specific, predictable patterns that pop up at the same time. But a good detective doesn't just look for clues that support their theory. Nope. They actively look for evidence that could prove them wrong. This next part is all about that due diligence, thinking ahead to avoid the common traps that lead to false discoveries. And this is the question every single good scientist has to ask themselves. It's not that the data is trying to trick you, but it can be really misleading. A pattern might look like a huge discovery, but it could be caused by something else entirely, and those something elses are called confounds. So, the framework actually makes us list our alternative suspects, these potential confounds, before we even start the test. For our solar circuit, could the signal just be the result of the normal day-night cycle? Or maybe seasonal changes? Could it be simple electronic noise from the equipment itself? We have to be able to systematically rule these other explanations out. So let's look at our mystery graph again. That big spike?
It could be the signature of this amazing solar circuit, or it could be the air conditioning unit at the research station kicking on during a hot day and interfering with the gear. A proper test has to be able to tell the difference.
So, after we've defined the claim, designed the test, and thought about all the ways we could be wrong, where does that leave us? What's the final resolution of our investigation? And here it is. This might be the biggest takeaway of all. Success in this kind of scientific audit isn't always about getting a simple yes or no answer right away. The real victory is transforming that initial confusing mess into a clear, rigorous, and testable plan. The clarity is the prize. So the final output from a Holmes audit is like a complete case file. It gives you a crystal clear hypothesis, a detailed plan for testing it, a list of all the ways it might fail, and even a shopping list for any more data you might need. It's a complete roadmap for the research ahead.
And that's the real power of this process. I mean, think about it. We started with a scientific mystery, this confusing document that could have been anything. And by applying a structured framework, we've turned it into a scientific mission, a clear, actionable plan to go find an answer. Which leaves us with one final thought. This whole process, it isn't just for confusing papers. It's a way to bring rigor to any new, bold, or complex idea. So what if every big idea had to pass a check like this before we all jumped in? What hidden truths might we uncover, and how many dead ends could we avoid along the way?